this video we'll discuss the vector product, or we call this as the cross product. This will be the last video for the topic of vectors. Okay, now what is A cross B? Or this can be written as A, vector A cross symbol, then B. Okay, the answer is the A cross B is to be the magnitude of A multiplied by the component of B perpendicular to A. So, if you remember in our discussion of the scalar product, we are talking about the product, okay? But in scalar product, we are concerned with the parallel component, or the component the same direction with the other vector. But this is concerned with perpendicular to A. So the A cross B means the product of the magnitude of A, okay, multiplied by the component of B perpendicular to A. Okay. Now, since this is vector, we still have one factor to multiply. Then, you have to multiply it by the unit vector in hat. In hat means the unit vector normal to the swipe area. This is the normal to the swipe area of the two vectors, because there, in this case, the plane of the two vectors is laid on the plane, and it will rotate. So there must be a swipe area. Perpendicular to that will be the vectors. So therefore, there are three factors. Unlike in scalar product that we have only the two factors, the component of A and the parallel component of B. We multiplied it, and that's the scalar product. And scalar product also, the result is scalar quantity. There's no direction. Although we have the positive, we have the negative, and we have the zero. But that negative is due to the direction of one vector to the other. Okay? So, therefore, in this case, the vector product, again, because of the word vector, the result must be a vector. So we can expect that the final answer involves the unit vector I hat, j hat, or maybe k hat. Another thing is the product is actually composed of three factors. The first factor is the magnitude of A, and the second factor is the component of B. Now this time perpendicular. So when we say perpendicular, it should be 90 degrees from the direction of A. Then multiplied it by the normal vector. This is still vector, but this is a unit vector, because the swipe area will rotate, and the rotation actually generates motion, which is in the direction of the normal of the area. Okay? So, suppose we have this one, two vectors, okay? Vector A, and we have vector B. Then, we have the angle coming from A to, if you notice in scalar, we still have the angle, okay? Almost the same, but the angle direction did not affect. But this time, we are now concerned with the angle. So, the angle, in this case, if we have A cross B, the angle must be coming from A towards B. Now remember that the swipe area will rotate. So the rotation is according to the direction of the angle. So the swipe area is this area, or the plane that the two vectors laid on the that plane. So in this case, this colored pink plane will be the will be the vector A, and vector B lies on that surface. Okay? So, therefore, if we take A cross B, this swipe area will rotate. And the rotation is, actually, it will rotate with respect to this point, the point of intersection between the two vectors. It will rotate at this point. So this will be fixed, while this one will be rotating. So the definition says that the A cross B is actually the product. So therefore, we have to find the magnitude of this, because the product of the magnitude of A multiplied by the perpendicular, okay, component of B. This is the perpendicular. This is the broken red line, yun ang arrow. This will be the component of B, which is perpendicular to A. So in this case, we will establish an axis here. So therefore, this B has a component parallel and component perpendicular. Okay? So this will be the component, and this is what? This is B sine theta. The magnitude of B multiplied by the sine theta, because take note that this is, the angle is adjacent to the parallel. So the perpendicular component must be in sine. So we will multiply this to the magnitude of A and the magnitude of B. Okay? So then, this will rotate. The rotation is actually the normal. So, the first factor is the magnitude of A. The second factor is the component of B perpendicular to A. Then the third factor is the normal hat. And the normal hat, or the unit vector in hat, is actually normal to the area. So, if this is the area, the normal should be in this direction. It should be perpendicular to the plane. That's normal, the meaning of normal. Okay? And this is the direction of the normal hat is the direction of the swipe area rotating. So therefore, the rotating swipe area will rotate about this axis, about the normal line, then it will move in what direction? It will move upward. So it will rotate. It will rotate. While rotating, it will be moving upward. Okay? Moving upward. Okay? So this is the one. This is the illustration. This is vector A and this is vector B. And the angle is coming from the A towards B. So then, normal to that, normal, this is a normal, okay, normal, or, okay, this will rotate in this direction. So, this is a swipe area, and this is the component of B perpendicular to A is somewhere in this point. This is the component of B. This is B sine theta. So, this one multiplied by this will be the swipe area, and this will rotate. This will rotate. Okay? So, this will rotate in the direction of the theta. While rotating, it will move upward. So, this will be the result. It will move upward. Okay? So, it is just like a screw. When you drive the screw, penetrates the wall, you have to rotate it in a right hand roll. So you can put your thumbs up, then the curl, or I think the curl of the fingers will be the direction of the swipe area. So it will rotate. While rotating, it will move upward. Okay? So again, it is just like a screw. So the screw should be rotated in this direction, so that it will be moved towards upward. So it will penetrate on the ceiling. Okay? So all you need to do is to think of the right hand. You put your right hand on the line of the normal force, then let your thumb stretch towards the direction of the unit vector in hat, then the curl of your uh, fingers, the curl will be the direction of the rotating, or the rotating swipe area. Okay, so that's it. So therefore, the cross product is actually a vector. Why? Because it is moving in the direction of the normal hat. So therefore, this will be the formula. The formula, or the cross product, actually contains of three factors. The A cross B means the magnitude of A times the magnitude of B multiplied by the sine function. Take note, sine, because we are concerned with the perpendicular. In scalar, we use cosine because cosine is adjacent. So therefore, it should be parallel. Now in this case, perpendicular must be sine. And this will be the unit vector in hat. This is normal to the area. Remember, this is 1 unit. So therefore, if you multiply A magnitude and B, it is actually the magnitude of the cross product. And the direction will be the direction of your in hat. Okay? Now, what do you think if we reverse the cross product? A cross B, this is the result. What will happen if we reverse B cross A? So if you reverse the angle, direction of the angle, if you reverse this angle, then what will happen is, instead of having rotating this direction, it will reverse. So once reversed, it will move downward in the direction of the thumb. This thumb will be the direction of the swipe area while rotating. So in other words, the A cross B is not equal to B cross A. Unlike in the scalar product, that the A dot B is equal to B dot A. There's no difference between the two products. But in the cross product, they are different to each other. Why? Because the direction will change. So for A cross B, it will rotate in this direction and moving upward. While the B cross A, rotating again but in a reverse direction, and it will reverse also its direction while rotating downward in this case. So therefore, they have the same. The only difference is this will becomes, in hat becomes negative. Because if in hat is upward positive, then the direction below should be negative. So the difference is only the direction. So practically, the B cross A is equivalent to the negative inverse of the B cross A. So the B cross A is a negative cross product of A cross B. So they are of the same magnitude but in opposite direction. So they are not equal actually. Unlike for the scalar product. Okay? So we call this as the property. This is the property of the vector product. Okay? So that's it. Now, the question is, why we study cross product? The answer is because there are many applications of the vector product or the cross product in physics, in studying physics. Now, one of the application is actually the torque or the mechanical torque due to the force. Because torque, remember, is force times the moment arm or the torque arm. But it is not just by multiplying, okay? Because it is, the right term is, it should be the cross product, the force cross torque arm or the moment arm. Okay? So if you evaluate this one, this will result what? A magnitude of, remember, this magnitude of F times magnitude of R times sine angle of between them, then the direction of the normal. Okay? So if the angle is 90, what will happen? If the angle is 90, sine of 90 is 1. So therefore, the torque is force times the torque arm. Just like in work done in scalar, work done is F cross S, displacement. So the magnitude of F multiplied by S niya cosine. Now, if the two are parallel, then cosine of 0 is 1. So, work is force times displacement. But torque, okay, torque is force cross displacement or the torque arm. Now, in electricity, for working with dipole, electric dipole, we have another torque. The torque of the dipole, actually, after substituting the force with the combination of this is the formula, but we replace the force with the electric force, then substituted, then this will be the result. But still there's still have the cross product. So the torque of the electric dipole is the P with arrowhead is actually, this is the dipole moment. So it is a vector. If we cross the dipole moment with electric field, E is electric field, is actually the torque of the electric dipole. And there are lots of applications of the cross product. So we need to study the cross product. Okay? So, now, question is, what is the cross product, vector product of unit vectors? Just like what we did in scalar, but we find the dot product of the unit vector. So we found out that the I dot I is 1. Okay? The J dot J is 1. K dot K is 1. Because the dot of itself, because they have the same direction, then the dot product of I dot I is 1. But I dot J, or if the angle between the two unit vectors is 90, then it will provide 0. So it is between 1 or 0 for the unit vectors. Now, what about the cross product of the unit vectors? Okay? So, for example, what is I cross I? So, use the formula. This is the basic formula of the cross. It should be what? The A cross B means the magnitude of A. So, take the magnitude of A, then multiply it by the magnitude of B. So, we have this one. Then, you have to take sine. Why sine? Because perpendicular component is our concern. So, we have this sine of P, or sine of theta. So then, this, remember, this theta is the angle from what? From vector A towards vector B. So therefore, this should be taking the sine, then that's it. Now, this one is the normal. This is actually following the right hand rule, or the right hand rule, okay? So you have to follow the right hand rule for the direction of your normal. Okay, so I dot I means magnitude of I is 1. Magnitude of another I is 1. Now, take note that this is what? The angle between them is 0. So, the sine of 0, take note, is 0. So, if you multiply 0 with 1, 0 times 1, 0 times in hat, 0. So, the cross of itself is actually 0. Why? Because the cross of itself has the direction of the two, the same unit vector is 0. So, the sine of 0, remember, is 0. Unlike cosine, the cosine of 0 is 1. But the sine of 0 is 0. Okay, so it follows that the J cross J is also 0, K dot K is equal to 0. Now, what is I cross J? Okay, so what is I cross J? So in this case, this is I and this is J, but J is, take note, 90 degrees from the A, or from the, this I. So therefore, the angle must be 90. So it is 1 unit of I times 1 unit of J, sine of 90. What is sine of 90? 1. Okay. Now, the direction is what? K. Why? If this is I and this is J, sa direction, the normal force is along the z-axis, and the z-axis assigned that with k hat. So therefore, this will be rotating while moving upward. Okay? And this is K. So, we use K. Positive K. Okay? Now, if we reverse it, J cross I. So, state the formula. 1 times 1. The angle is the same. Okay? But, take note that this K is a negative value. So, this must be negative. Can let's check this one. Or, correct this one. This is negative K. Why? Because, if you reverse the angle, if you take the J cross I, the direction will be, instead of having this one, it will reverse. So when it reverse rotating, it will also change its direction while propagating towards the below. Okay? The K is upward, then the K, negative K should be downward. So that's why the answer is the J cross I is K. Okay? Now, in order to understand, I know that this is very complicated if you did not understand clearly. Now, the strategy is you have to use your right hand. In your case, in my case, I used left because I am on the screen. So, this will be your right in your visual observation. So, this is, use your right hand roll like that. Okay? Then you have to face this in your eyes. This should be in the front. Okay? So then, what will happen is, you can assign this. This will serve as the three dimensionals. We can assign this as X. Okay? So assign that as, okay, you can assign this as X. So therefore this should be I hat. Okay? Then this one. This one. This is J hat. So the direction now is that way. J hat. And this is K hat. So therefore, from X or I, J, K. So in this case, the I is upward, positive, downward, negative. J hat or the XY axis should be pointing in this direction, positive. Reverse is negative. Towards you, this is K. Towards you is actually positive K. And the reverse is negative. So you can use your right hand roll, but you have to look at this face. Okay? So, the most important is you have to understand that this is positive. So, the rotation now is from I towards J towards K. So, the direction of the angle is like that. So, in that case, I think in your orientation, this will be the counterclockwise. This should be the counterclockwise direction. So, therefore, we can assign that the counterclockwise to be a positive angle because you followed by I hat, J hat, and K hat. Okay? In your right hand rule. Take note, right hand rule. Okay. So, the I represent again the axis along X, J, Y, K, the Z axis. So then, okay, then this is like this. We have the I, J, K. So the angle must be, but take note that the I and J, the angle must be, the I and J is 90 degrees, while the J and K, the X and Z axis is actually 90 also. So the J hat and the K hat is also 90, while the K and I is also 90 degrees. Okay, so that's it. So the angle must be, this is positive from I, J going to K. So in this case, look at this one. Why is it that this is K? Why is it that this is K? K hat. The reason is because the angle starts from I. Please follow. This is your I hat. Then you have to cross it with J. So it follows the right hand rule. Positive in the counterclockwise. So this will rotate. This area, swipe area will rotate in the direction of positive k hat. In the direction of positive k hat. So it should be positive k hat. Okay? Did you understand? Again, I cross J. So this will rotate in this direction. So while rotating, it will move towards the positive K. Now, what will happen if you reverse? I will reverse the cross product. J cross I. So if J cross I, this will rotate in a clockwise. So clockwise direction will provide motion reverse. So this area, swipe area will rotate backward. Okay? Not towards you. Towards the screen. Towards the screen. Okay? So, that's it. So, we will verify. So, all you need to do, if you are asked to find the cross of the unit vectors, think of this. I, J, K. Okay? I, J, K. The angle is counterclockwise. So, if I take I cross J, the answer is positive K. If you reverse J cross I, it should be negative K. Did you get it? Okay. Now, what is I dot I? That is 0. Okay, this is already answered. Now, I cross K. What is I cross K? Okay, yeah. Do not see this answer. What is I cross K? Go back to your finger, or look at the right hand rule in the screen. We have I, this is I, and this is J, and this is K. So you are about to take the cross product of I, cross it with K. I cross I, this is your I, cross K. So the direction is, take note, is, this is reverse. This is clockwise direction. So the angle must be negative. So if the angle negative, then your unit vector should be in the reverse direction. So therefore, you have to use J. Okay? The swipe area is in the plane of XZ. So the direction should be along y-axis. So therefore, this is always J. In this case, because it's I, K. So the missing is axis is the x-axis. So it should be J hat. And negative because it is a clockwise direction. Now what is J cross J? 0, because sign of 0 is. Now what is J cross I? J cross I is reverse. It should be negative. If you reverse K, what is I? What is J cross K? So if you notice, J cross K, positive angle, just like A cross J, positive. The J cross K is positive. So therefore, the answer must be I. Positive also. It should be I. The screen is I. This is, look at the screen in the right hand. The J cross K is positive. Okay, so if positive, then this should be towards upward. So therefore, it should be positive. I. If you reverse it, K cross J, K cross J, the answer is negative I. That's it. Okay? So, do not memorize the cross product of the unit vectors. Use your right hand. Always bring your solution towards this strategy. Use your right hand. And you can assign. So, all you need to do, okay, I assign this as I, J, K. You can rearrange this one. But, take note, if you rearrange that, look at your right hand roll. Okay, it's like that. So you can assign this as X. If this is X or I hat, this must be J, and this must be K. Why? Because this should be in a counterclockwise. Now, if you assign this as I, okay, I hat, this must be J, and this must be K hat. So that the angle must be in a counterclockwise direction. Okay? So that's the strategy. So when you ask to what is I cross K, I cross K, I cross K, it is counterclockwise or clockwise. So therefore it should be negative J. Okay, just practice, then you will learn. This is very important because we will now derive the cross product. The cross product, what will happen if the B, an A vector, is in terms of unit vector? So what is now the cross product? Okay, just like what we did in scalar product. So we found out that the dot product of the two vectors, it comes up with the product of the component along X plus product of the plus the product of the component along Y plus the product of the component along Z, then add. Okay, and the rest is the product. Why? We use that because we derive the relation by scalar product. Today we will derive again what is the cross product of two vectors using its component, and it should be in terms of the unit vector. And take note that the answer should be vector. So if it is a vector, make sure that there is a presence of I hat, or maybe in Z hat, or K hat, or both of them, or one is missing, as long as there must be unit. Unlike the scalar that the unit vectors are totally eliminated. Okay, so by the way, K cross I is J, so it is counterclockwise, so this should be positive. Okay, suppose we have this A vector A and vector B in terms of its component with the presence of the unit vector. So the question is, what is A cross B? Okay, evaluate just like what we did in our previous. We have to change A or replace A with this given and take the cross product of that. Okay, so take the cross product of this. This is B. Now next is to evaluate or distribute in order to remove the grouping symbol and in order to combine. So all you need to do is to, just like what we did in previous in scalar, that we multiply this first term to the first term, then this first term again to the second, then first term again to the third, then followed by the second to the first, to the middle, to the third, 3 times. And this is also distribute by by distribution. So then first factor is multiplying this one with this. We have EX, BX, I. Take note, we isolate the vector, should be cross I. So EX, BX, I cross I. Then next, EX, BY, I cross J. Okay, so EX, BY, I cross J. You cannot interchange, because if you do it, it's different meaning, it changes its direction. So you have to follow the order, I cross J or I cross I. Okay, now last factor for the first term, multiply this with the last term to the last first term to the last term. We have EX, BZ, I cross K. EX, BZ, I cross K. So these are the factors in the first term only. Now second term of the component of A, so it should be AY, BX, J cross I. Okay, EY, BX, J cross I. Next is AY, BY, J cross J. Then finally we have AY, BZ, J cross K. Can you follow? It is just like an algebra, distribute, but careful with the unit vector. Do not interchange and put that into a grouping symbol, because you can reverse the components AY and BX, but you cannot reverse the vector because it has different meaning when you reverse it. Okay, then here comes the last term of A, distribute to all terms of B. So we have EZBX K cross I. EZBX K cross I. Then, next, EZBY K cross J. EZBY K cross K. Then last, EZBG K cross K. That's it. Now you can check this. It should have 9 terms because this each term provides product of factors of 3. So 3 times 3 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. So there are 9 terms. So the grouping symbol was eliminated. Okay. Now, what is the cross of itself? Remember in our previous slide, the cross of itself is 0. So this must be 0. The I cross I is 0. While the J, where's the J cross J is also 0. And this K cross K is also 0. So 3 terms was already eliminated. So we have only 6 terms left. Okay. What is I cross J? The answer is K. So this is K. Now what is I cross K? I cross K. This is clockwise. So it should be negative J. This is negative J. I cross K. The angle is clockwise direction. So therefore, this should be, the rotation should be in the reverse. So it should be negative J for the I cross K. Okay. What else? Okay, this is J cross I. J cross, take note, J cross I. So what will happen is this is clockwise. So therefore this must be what? Negative K. So this is negative K. What else? J cross K. This is K. This is J. J cross K is what? This is counterclockwise. So therefore it should be positive I. It should be positive I. Okay, then what else? K cross I. K cross I. So K cross I is, again, it is the counterclockwise. So the angle is positive. So therefore it should be positive J. It should be positive J. Now we have K cross J. K cross J. This is clockwise. So therefore, it should be a negative I. Okay, so therefore, replace these values to, then we have this result. The AXBY is K times K hat. Then we have the AXBG is times negative J hat. This is this is again negative K, and this is EZBY is I hat, then plus EZ, this is EZBX J hat, then this is EZBY negative I hat. So these are, the 3 are 0. These are 0. So we have only 1, 2, 3, 4, 5, 6 terms. Okay. Now, okay, there are 3 negative terms. This is negative, 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 and this is positive. There are also 3 terms which are positive. Okay, combine the positive. So this is positive, so leave it as is. This is negative, so transpose this. We have the positive, EY, positive. Where is positive? Okay, this is EZBX. Okay, then we have the EY, this is, okay, wait, EYBG is this one. Okay, then EZBX is EZBX. Where's EZBX? EZBX, this one. Okay, then we have EXBY, this is AXBYK. These are the three positives. The three negatives, also we have EY, this is AYBX hat, and we have the AZ, this is AZBY hat. Then finally we have EXBZ, this is AXBZ hat. So we arrange this one, combining all positive. Now this is now the result. Okay, so meaning if you take the dot cross product of A cross B, this will be the result. But it's hard to memorize this one. Now if you analyze this, if you evaluate this determinants, this is determinants, 3 by 3 matrix, 3 by 3. So if you evaluate these determinants, actually you will arrive this result. So you have to recall your algebra, the evaluating the determinants. So if you evaluate these determinants, there are many strategy. Okay, the first is you can repeat these two columns. So repeat these two columns. Okay, or you have to take diagonal dot. If you take diagonal of this AYBZ, actually this is the result, positive. Then if you repeat this line, you are multiplying Z hat AZ BX. Okay, so if you repeat this line, it will be placed here. So another drop diagonal is positive. This is the result, AZ BX J hat. You understand? Now if you repeat these two here, then you come up with K BX BY EX. So this is EXBYK. That's it. These are the diagonal, drop diagonal, and these are all positives. Now the negatives are the reverse diagonal, diagonal up. So this is the AYBXK hat. This is the one, negative, because reverse diagonal. If you repeat this column here, then it will be AZBX I hat. So this will be, okay, this is the first, and the second is should be this one, because if you repeat this, it will be placed at this point. Then the third is actually, if you repeat this two here, you come up with this one, and we have these results. So actually this method is rotating method. So we did not repeat the two columns, but we are imagining that these two columns are already positioned this point. So this is the rotation method. Okay, or if you do it this way, repeat that first two, recopy this one, then drop diagonal. This is the one. Then the next is this red color is actually this one, so it should be BX. So the BX is here. Then the green, it should be K multiplied by EXBY. These are the positives. The first drop diagonal here. Then we have the up diagonal. Then actually this one rotate. So therefore these two are the same. So if you evaluate this, okay, the result shows that this is this. So no need to memorize this one. All you need to do is to put that onto the 3 by 3 matrix. Look at this one. The first row, the upper row, the first row will be placed by the unit vectors. It should be I, J, K. So this is the position of the unit vectors. The second row will be occupied by the components of A, not component of B, because we are taking the cross product of A cross B. So the middle row should be occupied by the component, and this should be arranged accordingly. This should be the X component, because this belongs to I, and this is the Y component, because this is Z hat, and this is K hat is Z. So therefore, then the last column of the 3 by 3 matrix will be the components of B, BX, BY, BZ. Okay? So that's it. So no need to memorize. So therefore, when you are asked to take the cross of that, think of determinants. Again, the first column, unit vector, or first row. Then the second row is a component. Do not include the I hat and Z hat because these are the component. Then we have the last row for the components of B, arranged from X to X, Y to Z. So, you can notice that if you evaluate this one, there must be the presence of unit vector. In this case, we have I hat, Z hat, K hat, okay? Then combine the like terms. Then that's it. In the cross product or scalar product, we don't have the unit vector, but in the cross product, there must be a unit vector because it represents direction. Okay, there's another way. There are many methods to evaluate these determinants. We can combine like terms. This is I and this is I, so you can combine this. Then take out the common. The common factor is I hat. We have also the common factor. The like terms are terms that have the same unit vector. So this one and this one are like terms. So we can combine these two. And this one is also like terms. So if you do it, okay, if you arrange this, take the common factor, combine like terms, this will be the result. Okay, this will be this one like term, these are like terms. Then take the common is I, and this is the common is J, the common is K. So we take the common, so we'll leave this value. We have AY BZ plus AZ BX. So this result is actually after combining like terms. So in that case, I think this is the simplest way to calculate. So therefore, if you evaluate the determinants, you can do it this way. Look at this one. First, take note that this is already the answer because this is I hat, J hat, and K hat. So therefore, the first term of your answer of the A cross B will be this one is positive. Okay? So AZ, AY, BZ. Then the reverse must be what? The reverse must be this one. Then multiplied by, so this is the drop down positive, and the diagonal up is actually rotating that in the position. So okay, so therefore if you evaluate this one, you are actually solving the component of the cross product. The I component or the X component of the cross product A cross B. So therefore this is already the answer. Then second term of your answer will be what? Okay, then this is J. You can hold this point, then take the drop diagonal, rotating. Then we have the EZ, BZ, this one, BX. Then the reverse is what? The reverse is EX, B, J, then cross, rotate to BZ, this one. So therefore, we have already the second answer, second term for our answer. Simplify, then that's it. Then our last term for the answer is this one. The first diagonal is the positive is K or 8EX BY sorry. Okay, then the negative is AY BX. Diagonal up is AY BX K. That's it. This is the answer. Or another method is elimination. Sorry. First is you can eliminate X or I. So you have to do it. So this is not included. Now look at this one. This result actually AX AYBZ is actually this one. So this should be positive. So in this process you are eliminating I. And this one is the reverse. So this one is the reverse. So this should be negative. That's it. You are already calculating the first term of your answer involving I hat. Now this one is actually, if this one you eliminate I, so this time you have to eliminate the J or cancel and this is the intersection of part. So therefore, these are eliminated, the I, J, K, and this one, BY and AY and BY. So we have only 4. Actually, we are reducing, this is 3 by 3. In this case, we change this into a 2 by 2 elimination by, you're eliminating one variable, so we come up with a 2 by 2 matrix. And this one, we eliminate the middle, and we have remaining EX, BZ, BX, AZ. So therefore, this will becomes 2 by 2 matrix. So to evaluate is, because this is in the middle. Now, if you notice here, the drop diagonal is positive, and the reverse diagonal downward or upward, this is negative. Now, in the middle, this should be reverse. This will be the product of EZ, BX must be positive. So this must be positive. Look at this one. And the reverse, okay, is negative. So notice the color. This is blue, and this is blue. So for I, this is positive, but for Z, this must be positive. Then this will be negative, and this will be negative for J. Now what about so therefore you notice this is the result. Now finally, for the last term, this one, you can eliminate K. So you are now reducing from 3 by 3, reducing only by 2 by 2. So take diagonal product. Now the positive is the same as the I. Okay? Only the middle differs. The middle part, the J. But the K and I are the same. This is positive. So this is AX, BY. Then minus AY, BX. Okay? That's it. So, very easy. So, I think this is I recommend this method. This is the simplest method so far. Or you can use the rotation. The rotation also is the same. Using this one. Using this arrangement. Okay. So, example. Suppose given vector F with the components along X and Y, Z, and this is Z vector. So, you are asked to find the cross F, cross J cross F reverse. We understand that the relationship must be negative. Okay, but we will show this that the the property of cross product is actually the same, or it has the same magnitude but in opposite direction. So the result must be a negative reverse. Okay, so what is F cross G? So take note of the formula. Okay, this is the arrangement. So you have to create the 3 by 3 matrix. The first term is, or the first row must be IJK. So this must be IJK. Then, because this is F cross J, the middle, or the row, the second row must be the component of F, not G. So this should be 3, negative 5, 2. Again, 3, negative 5, 2. Okay, then the last row will be the components of J vector. But take note, look at this one. There is no presence of I. We have only J and K. The J is understood to be 1 component. And this one is 7. But you have to include the sign. So, take note that we include the sign because our formula here, we assume as positive. But this differs depending on the given situation. So therefore, you have to include the sign. And remember that the K here, our unit vectors, are assigned in positive. So therefore, to carry the sign, it should be bring it together with the components. So therefore, we have this negative 5. So therefore, in this case, I must be 0. And this is 1. And this is negative 7. Again, this is 0 because there's no presence of I. Actually, the unit vector it doesn't have a 0 value. The unit vector is always present. It is the magnitude that makes this 0 term. So this must be 0, and this is 1. Okay, 1 for J, and this is negative 7. Okay, so then evaluate the determinant. So evaluate again, we use the easiest way, simplest way. So we have this one, then this should be what? Positive. So, negative 5, negative 7, positive 35. Okay? Positive 35. Now, this should be what? Subtracted by the negative diagonal. So, this should be 1 times 2, and this should be negative. So, it should be minus 2. Then, subtract this one. We have 33 I hat. This is already part of the answer. You're already providing the first term of your answer of F cross G. The second term is, okay, eliminate the middle. Okay? So, remember that reverse. The middle is different from the sides. So, we have this one as positive now. So, this is now the positive, 0 and 2. 0 times 2 is 0. So, this, therefore, it should be 0. Okay, we have this J and we have this I. So, we have another term here. So, the other term is the reverse. And this is now negative. So, 3 times 7 is negative 21. And because negative, this negative, this should be positive 21. Did you understand? Okay, again, this is 0. Okay, this is 0. Now, the reverse, because positive, this is positive. So, leave it at 0. This one is, this should be a negative product. So, if you multiply 3 times 7, negative is negative 21. Negative and negative becomes positive. That's it. Second answer of your cross product of F cross G. Then, finally, this one. So, you have to go back the same treatment as I. So, this must be positive now. So, the 3 times 1 is positive. So, this must be added by, always add. Okay? Added by 3. Do not subtract. Remember, do not subtract. This should be add. The subtraction will be happens only inside the grouping symbol. So, therefore, this must be 0. So, it should be 0. So, remember 0, you cannot subtract. Just put the sign because this is 0. So, simplify. The answer is 33 plus 21. 33 I hat plus 21J plus 3. Okay, then reverse. Now, letter B, B cross F. So, therefore, this will be interchanged. The unit vector is the same, but this one will be put below, and this one will be elevated at the middle. So, therefore, you have to change. Why? Because this is always a unit vector. This will be, the second row must be the component of the first vector because you are looking for the G cross F. So, this must be the component of vector G. And this is vector F. Okay? Then, use the same procedure. Eliminate this one. So, we have positive 2 and this is what? Positive. This is positive 35. This is positive 35. Because this is negative diagonal. So, therefore, 2 minus 35. 2 minus 35. There, this one, cancel this one. So, this is positive. So, this must be negative 21. And this is minus 0. Negative 21 minus 0. Okay? This is positive. So, therefore, because we are in the middle. Now, in the last row, so you have to eliminate this one, go back to the original. This is positive, so this is 0, and this is minus 3. So, 0 minus 3. And the answer is, look at this one, almost the same. It differs with sign. So, if you take the common, or, because you can provide the answer with 0, negative first term, so, sign preceding, we have negative 33 I hat plus 21 J hat. And this is exactly the value. So, therefore, we can say that the G cross F is actually the negative of F cross J. Okay? So, this is actually, this is consistent with our property previously discussed. I hope this is clear to you. All you need to do is to go back. If there's something that you did not understand, then go back this video, then go back again until you will learn. This is all about the unit vector. So we are done discussing the important requirements in studying physics, the vector analysis. So if there are something that makes you difficult, go back all the videos again, then absorb everything, and I'm sure if you understand, you will be confidently uh, follow the next videos, because the next video will be talking about the kinematics. So it is now the part of the physics. This is just the review of the fundamentals of physics. So this is very important, because when we study electricity, again, electromagnetism, again, this is vector analysis, very important, because it involves physical quantities, vectors. Okay, so for your practice, it is a good exercise. Solve this in your own idea. If there are something that makes you difficult, then go back again the videos, then try to solve again. So the strategy is combine this first using the, because we have the priority, the grouping symbol. So then after that, the result must be dot to L. Okay, so thank you for listening.